the lead on this, and Andy is also on this project, but just going to kind of give you a brief overview of it. If I can get the screen sharing to work here and get that. Okay, it should be good. If it wants to go full screen. Okay, that's not working. Oh, and I got two monitors and it's not behaving right. Display settings. Does that look good to you guys?
Yes.
All right,
You're okay
cool.
if I record, right?
Yeah, you're fine. That's totally fine. Some of this is a lot of this is actually cribbed from Carlos's presentation at the at CMS, but I was gonna for this I was just gonna focus really primarily just on methods, and it's also kind of helpful to get feedback from you guys. So the kind of goal of the project is the multi-scale data fusion prototype system. The idea of developing carbon dynamics monitoring specifically for the Brazilian Cerrado, which kind of stems originally from an effort to do, kind of fire and fuel modeling within this area. So summed up again is to develop this kind of, prototype carbon monitoring system with this idea of being in 4D, so spatially and temporally resolved, building up, above ground carbon mapping to create kind of wall-to-wall maps kind of over time, specifically for the goal of both mapping, but also monitoring above ground carbon responses to, disturbance, land use, et cetera, specifically in the Cerrado. To bear down more, which I think is probably more useful for you guys for this, because I figure this is not really necessarily an overview. The specifics goals of this is, first, develop new calibration models for estimating, canopy, surface, and in total above ground canopy, first at the footprint level in the Cerrado. And so I'm going to go through these a little bit more specifically and what they entail later. But that's the first goal, is to build those calibration models from ground data that was collected in 2019, as far as like carbon measurements, and also remote sensing data that was TLS data and drone data collected in 2019 and 2021. Second, is to develop a multi-sensor data fusion approach, specifically using like parametric and machine learning methods. The idea of this would be to build from those footprint level models that are informed from ground data to basically kind of bridge this together using Landsat or some type of synthetic aperture radar to be able to build wall-to-wall above ground carbon maps for this area. And then three is to do the same thing, but just to do it over time. And then specifically within that, get into error, uncertainty, quantifications, and then also start to look at dynamics and interactions with fire. Cerrado is kind of a fire adapted system. And this will specifically kind of help to address the stakeholder portion, of the project, which is, a big portion of this project. And then four is to be able to quantify those distributions of above ground carbon across the Cerrado to be able to look at new environmental conditions such as fire frequency, intensity, or even burn severity, and specifically, again, land use, land change, how that affects this, kind of spatial and temporal variation of above ground carbon. And then kind of also specifically looking at how fire suppression can impact the balance of carbon. This kind of plays into that fire and fuel modeling aspect. So to kind of orient you, the Cerrado is are specific sites that kind of went into the field study for this, like the field collection data part of this included a few national parks and some national forests and some other areas moving from grassland to forest across the Cerrado, which is kind of like the southern Brazilian area. And so I unfortunately didn't get to go on the data collection side of this. I kind of came in after that, which would be, it was kind of a bummer, honestly. So hopefully I get to go out and do some of the education next year. Andy, were you part of the data collection for this effort? You're on mute. No, he says no. Okay. All right, so kind of bearing down a little bit into kind of each method step by step, which I think would be of interest here, is the first is that being able to build a multi-layer above ground carbon model. So this was, again, informed from field data collected in 2019. So on the right side is kind of the breakdown of how these data were collected. So, taking general DBH of trees that were all above 10 centimeters, then looking at DBH for shrubs and small trees using allometric equations and to be able to relate those to total biomass, and then looking at surface fuels, again, doing like a cut, collection, 1 meter square, weigh, and do everything. The shrubs were done in like kind of a general transect method. So that's kind of what came into building all the kind of the above ground carbon, that aspect of it. The data collection that went along with this remote sensing wise was like the UAV LiDAR system that kind of collected. This was using the Gator Eye drone that Evan Broadbent at Florida kind of runs. And additionally, some TLS scans were taken as well using a terrestrial LiDAR scanner. To be able to move from the above ground carbon estimates using the ground measurements to something that we can then kind of build from, this involves taking those remote sensing data and then using like the JEDI simulator that's built into the R JEDI package primarily, can take those point clouds and then put them into JEDI similar data. It adds a little bit of the noise and makes the data look nice and compare it to JEDI products. From there, we can pull the level 2A, 2B data that you would see off of JEDI from those simulated waveforms. And then we can use that plugged into a model that then connects to the actual above ground carbon in this multi-layer kind of setup that we have. So it just kind of connects that ground data to the remote sensing data, or simulated remote sensing data rather, that we can then plug in and move on to kind of step 2. This was kind of validated a few years ago in last year is when it finally kind of came out in the RSE read by Rodrigo. So it has a kind of details a lot of that methods, and then the above ground biomass density measurements were then led by Maria Vitrez as well. Kind of came out in Forest Ecology and Management. So, we know these methods kind of work. We've kind of, worked on this, or others have worked on similar data specifically within this system. The Cerrado honestly works pretty well for this, being a kind of open savanna. The savanna system does make it a little bit easier to do this kind of approach, especially when you get into wall-to-wall mapping, because you do have that general more canopy openness. And we know that either Landsat or radar, or specifically JEDI, can definitely give you a more full characterization of what's going on there, and we don't have to necessarily worry as much about canopy cover and exposure that way. So step 2 of this is building that multi-layer model up to kind of like that wall-to-wall kind of step. So JEDI, as you know, is kind of like a general Swiss cheese of footprints, several prints, kind of along a track. They are done in like a 600 meters between tracks, 60 meters along track between sites. So it's kind of like a Swiss cheese piece of LiDAR that's collected, and then it's not all collected at the same time. So you end up having to do some integration to kind of interpolate that. And so, using Landsat, or like I said, synthetic aperture radar, creates a means to be able to kind of take the rich JEDI data and then using, more spatially dense, but not as well spatially resolved and structurally resolved data to be able to create a wall-to-wall map from that, which then using like kind of a general machine learning approach, typically fall into random forests or support vector machines, whichever your typical flavor is. We can be able to create multi-layer mapping from this. And again, this was a paper that Carlos led a couple years ago, showing that the ability to fuse these data together works very, very well. And we can build on even JEDI and bring in like ISAT2 type data, and to be able to expand, or rather increase the structural resolution that we can kind of resolve this, and kind of creates an opportunity. And then that begins the step 3, which is phasing that up in through time, and then being able to create kind of the temporal map using Landsat and ALS2 specifically from those reference data sets, from those multi-layer models, to be able to do this over time. And then this allows us to be able to track the use or the impact of land use, land change, or fire in the system, at least through the period that we're trying to do from 2019 into 2025. This will also be helped by the fact that JEDI will come back on board in 2024, and so we'll have additional information as well that may serve to just help make a better, stronger model, or it may, in some cases, just help to be a good reference check to see if what we had comes out pretty well. And that is kind of the 30,000 foot view of what we have. And with that, I will throw back as soon as I can unshare. I'm glad to answer any questions that I can.
Okay, thanks, Jeff. I can think of a couple questions, but I'll let anyone else ask first.
Yeah, just a simple question too, for like for data users like me, depending on the model you're using, it doesn't distinguish between the canopy level biomass and the surface biomass necessarily. And so what we could do is distinguish by like plant functional type or species, right? Tree species from the surface, which is traditionally like shrubs and grass. But you also have more like juvenile, like, trees or whatever as well. And so that kind of confounds. Is there any way to tease apart those two signals? Does so like, younger trees versus shrubs and grassland to get at that information?
It's theoretically possible. I think not within the design that we have. The design we have is more optimized to be able to get as accurate and precise a biomass estimation as we can.
Mm-hmm.
I mean, I see a possibility if one could, integrate hyperspectral type data into that. But honestly, having never applied that to the system, I don't know how easy that is to do.
Okay. No, that's fair. That's fair.
That would be great. I mean, I think that would be good. I think a lot of my work before this has been in temperate areas in the US where that's actually not that difficult to do because you have seasonality. But here you're just dealing with a wet, dry season, and it's a little bit more difficult. And you do have a little bit more prevalence of kind of deciduous broadleaf, or rather evergreen broadleaf trees that are there all year. Even though there's most of this is like dry tropical savanna.
Gotcha. No, that makes sense. No, I'm always thinking of ways to include more metadata, more precise information into the model. I mean, you could always include all the biomass, but it's a little bit more imprecise a comparison. But okay, I got it. Thank you.
Yeah, I suppose if you had really good, kind of species mapping, that might be possible. And I don't think it would be as difficult in all the range here, honestly. I mean, as you move to farther drier areas, you're going to lose some of that shrub cover, and it's just grass and some of the more dry adapted trees.
Gotcha. And then, oh, sorry, go ahead.
Well, Brett, maybe since we're on your question, are you familiar with post stratification?
Probably not. No.
So this is like if you took a biomass map, where you don't have species calls or functional types necessarily, but you stratify based on a map that does. So this is something that FIA does, and on my project, Francisco Morrow just published a paper on that. So post stratifying biomass estimates. So that's sort of like one option that might be helpful to you to,
So it's some post-process. So is it like, very simply like some post-processing stratification, essentially. So some post-process modeling kind of, you can look at it that way.
Yeah. So taking a biomass map, for example, and coming up with estimates for different veg types, for example, based on a map. And it might even be something you could do yourself.
How well typically, and this is the other big question, most data users, how well are the uncertainties propagated from kind of the raw product to the stratified product? Are those generally well quantified, the uncertainties?
I think so. Yes, I think so. Provided, they are in the biomass map itself. And I would imagine also the stratified map, the categorical map that you're using to define your strata.
Are the strata almost probabilistic though in their determination?
Well, as a result of a classification.
Yeah, they kind of run from that kind of like a classification algorithm is what spits it out.
Well, that itself will probably have its accuracy statistics reported, like with a confusion matrix.
Yeah. Okay, that's cool.
Yeah.
That's good.
Thank you.
But anyway, what were you going to ask next, Brett? I thought maybe you're going to kind of switch gears. So I wanted to just say that before you.
No. That was That was pretty much it. I'm just thinking about. I mean, to be honest, most of the biomass mapping that I do now, I mean, I just look at one overall quantity. When I compare it to the model, I take like the average grid cell, average across all the plant functional types. So, but I know it's possible to extract more information. So I figured since I had the experts on this call, I would just, I was just curious, like scientifically, how hard it was to get at more of the data. So no, that was a good. Yeah, I'm happy. Thanks.
Okay.
No, that's an interesting point. Good to think about.
So I could share that paper with you that I just referred to, like a post-stratification analysis.
Sure. Yeah, you want to put it in chat?
Okay, yeah, let me do that. I'll ask my question first while I look for that, while Jeff answers. So, you put that paper up that Carlos led with simulated JEDI, ISAT, and ISAR.
Yeah.
And it just sort of got me thinking, JEDI is kind of designed for forest systems. And you remarked how the Cerrado is quite open, at least in portions. And our project is looking at that continuum between grassland, savanna, forest. But it just makes me wonder, why aren't we looking at ISAT-2 data? Because that's, in theory anyway, better suited for lower biomass systems. Of course, it was designed for ice sheets, but JEDI may not be the ideal tool for low biomass systems because of its own design for forest. And you get convolution of the signal, trying to identify separate the ground from the vegetation in those short stature conditions. Any comment or thoughts about that? Like
I think we, because we have the ISAT-2 project funded as well, but that's more focused on disturbance and hurricanes. We already kind of have the pipeline set up to do that, and I think like augmenting this with ISAT-2 would be ideal because like you said, like ISAT-2 does a little bit. It does better than JEDI when you get below, below 90% canopy closure. Like it does a little bit better job at some things. And then it kind of falls apart once you get above that level of canopy cover. And I think NISAR does similar. I can't remember the specifics on NISAR, but it's not up yet anyway. So ISAT does have an advantage, or not advantage, but it does kind of create the opportunity for, again, like a little bit more added data and added information, which I think in this system would work well. I think where ISAT kind of tends to struggle is when you get into, like I said, large, big, tall, mature forests. That said, like JEDI still does a little bit better at getting resolving what's those lower strata, like having that information is a little better because ISAT's just a few photons. It's a 10-meter footprint. Like it has other eccentricities that make it a little bit less than ideal. So I think actually being able to bring in as much data as you can here is definitely a help. They do tend to come up. I think one of the things from that paper is that they do tend to come to different answers in biomass for different reasons. Like I think ISAT-2 generally tends to underestimate compared to JEDI in particular.
Yeah. So that's another harmonization effort that's happening, I guess, is trying to harmonize between JEDI and ISAT-2 derived, say, biomass estimates. But yeah, I guess it's a little apples and oranges. So maybe that's, well, a lot of apples and oranges. So it's not an easy thing because it's just such fundamentally different sensors.
Yeah.
So maybe that makes it harder to develop a product, say in savannas, that would leverage both.
Let's see. One of the things that we're working on as far as the ISAT-2 science team is one of the first products we're trying to push is because there's only, I think of the 20-ish projects funded, only 3 of them are terrestrial vegetation focused in general. Is that and Amy, and I cannot pronounce her name correctly, but Amy Neuschwander is leading it.
Neuschwander. Yeah.
I was really close, but yeah, she's leading it. But I know like Carlos and I are contributing to a paper like kind of reviewing and outlining the possibilities for ISAT2 for further, kind of terrestrial vegetation usage. And one of the at least more interesting sections of that paper so far to me is the synergy section. Like, where do current and other future spaceborne, remote sensing platforms kind of align to help increase the use of ISAT2, but also like where can ISAT2 be, kind of additive? And big in that is JEDI and NISAR in particular, because they're all three of them are pulling like force structure information. They're just doing it a little bit slightly differently. And then in places where you can get all three, and I think that paper shows, Carlos is from 2021, it's better, and you get a better response to it. Like the general, like putting all three together do pretty well, but not necessarily everywhere. Like in some cases, it's the combination of two of them do better than the other. So it's not always that all three do the best, but it doesn't hurt.
Right. Well, usually more information means more variance explained.
Yeah. It's when you get into like the really large, dense forest, like when you get into like rainforest areas, if I'm remembering it correctly, you're pretty much best just to go with JEDI, honestly, in those areas.
Yeah.
Unless we can parameterize the models better. Like that's always the other possibility, right? Like is the limit the sensor, or is the limit more the structural issues that we have with how we're approaching the modeling of it?
Right. So I put the citation in the chat, and it reminds me that that paper was focused on biomass change. I guess that was the novelty of it, and what that led to its publication. There's other pubs focused just on biomass and a post-stratification of that. Jacob Strunk has done some of that work, so he's a good name to search for. He's a statistician in the E&W station.
Yeah, he's really good. He's very thorough too.
Yeah. So you've heard of him. Okay.
Yeah, he works on the for Savannah. He's doing our like LiDAR forestry, kind of applications modeling stuff. Like he's doing that aspect of it.
Oh, cool.
Yeah. The actual
Okay.
growth modeling work.
Any more questions on Jeff's talk?
Yeah, I have one question regarding so hi Jeff. I'm thinking about how did you incorporate the fire disturbances in your system, and are you using some fire maps or some measured, or I don't know, the observed data to do that?
Yeah, so there was I'm trying to remember on the specifics of the data collection. I know that I cannot recall if there was pre and post fire data collection. I believe there to be, but I could be wrong on that. That may have been another project that I'm thinking of. But the specifically was using like that kind of stratified sampling to look specifically at, kind of surface fuels in the shrub layer. And then if I'm wrong about the data collection part, the supposition would be there that the surface level fuel would be completely burned, and so that you're getting that kind of fuel from that way. But I know there's other work that has been done in that area. And there's also, the name is escaping me. He's now in northern Arizona, but he used to be at Oxford. He's done a lot of work in this area too, specifically with LiDAR and fuel monitoring in that area. But the name's escaping me. Starts with an S. But yeah, it was more specifically doing that kind of stratified sampling allows us to kind of get at that, section in particular.
Okay, thanks.
Okay, thanks. Anything else? Otherwise, maybe I'll stop recording.
Yeah, that's fine. No, I appreciate it. Thank you guys for allowing me to come in here and ramble on.